So I think we're live. But hi, Kenny. Good to see you
Hey, Nina.
finally.
Good to
Yeah.
see you in person.
Yeah, same here. So I think we're live on YouTube, but we need to make the Binance Live link also work. So just give me 1 second. Let me do that.
Sounds good.
Okay, I think we're live on both platforms. And I'm
Sounds
hearing
good.
echoes again. Oh, wait, let me.
Oh, from me?
Do you hear any echoes?
I don't hear
Let,
any echoes, no.
yeah, I do hear echoes. So
Do you have yourself streaming on two different browsers or two different tabs? Because maybe you're hearing yourself from your own speaker.
okay, just let me fix this. Sorry, everybody in the live room, just give us 1 second.
Yeah, no worries. Maybe I'll just kind of say hi while we're waiting. Um, so, hey, everyone. Great to be here.
Yeah,
Glad
maybe
to be
Kenny, sorry, you can give little bit self introduction of how did you get into the zero knowledge space? When did you initially get to know about the concept, and then also a little bit introduction about Manta Networks?
Yeah, sure. Do you want me to do that now, or would you like to wait until the echo for yourself is
I think
fixed?
the echo is finally fixed now.
Oh,
So
yeah?
sorry about that. Yeah. So now it's all
Okay,
good. Yeah, we can go.
cool.
Yeah, go ahead.
All right. So, yeah, let me try to remember the question. So it's like two questions. The first is like, when did I first hear about zero knowledge proofs? When did we get into it? And then the second question is more about like, what is Manta Network and what are we kind of building there? So I guess it's a broader sort of conversation around my journey into crypto. I actually started off Bitcoin mining because I was running a cloud computing company a while ago, and when you run a cloud computing company, you have physical servers that are on 24/7, whether someone's using them or not. And so we had these servers, and so I just decided, okay, I've got to figure out some creative ways to cover the operational expenses of the servers that are running and consuming energy anyway. So I started doing some Bitcoin mining, and that's kind of how I fell down the crypto rabbit hole. And then around 2017, right, that's when I think the first decentralized applications really started taking off on the Ethereum ecosystem, and started really exploring different use cases, and had a friend who was studying at Harvard for his master's in econ at the time, Victor, and I was doing my MBA at MIT at the time. So we were basically neighbors, and we both wanted to explore sort of identity solutions in the crypto space, especially because at the time we were working a lot with enterprises, right? Like the KPMGs of the world, the accounting firms, the consultancies like BCG, even sort of government financial institutions, specifically looking at blockchain use cases. And I think it always boiled down back to personal sovereign identity and control over that identity. Um, and so what we started to realize is that everything on the blockchain, especially when it comes to thinking about decentralized applications, is becomes another data point that can become essentially a surveillance tool if there's no form of privacy. And so that's really how we got into the thinking about privacy, which led us down the rabbit hole of zero knowledge proofs, which is what we're talking about today. Um, and so, with that in mind, right, that's kind of how we started Manta Network as well, because so Victor and our technical co-founder Shumo, right, were exploring ZKPs more on the technical side, and we got together and thought about these types of use cases and how to apply it onto the blockchain. And that's exactly how Manta Network was born. And so today, Manta Network is operated by P0X Labs, and that's the team behind the Manta Network deployment. And we specialize in cryptography, on-chain cryptography and privacy using zero-knowledge proofs.
All right. So yeah, thank you for that. That's very interesting. So zero knowledge is quite the buzzword right now. So we actually did do some work on this before. We had another webinar focused on comparing ZK to optimistic rollups. But today we're going to focus on zero knowledge. So let's first lay the ground of explaining what is zero knowledge proofs.
Yeah. So, it sounds easy, but at the same time, it's pretty complicated because regardless of like as simple as the explanation may be, the reality is that the cryptography, the math behind it can get fairly complicated. But on a high level, right, a zero knowledge proof is essentially a methodology. It's a method, which means that there's many different approaches to doing what's called a zero knowledge proof. But the idea of a zero knowledge proof is that you should be able to prove something without revealing any information about that something. So if I can prove to you that I am of legal drinking age in the United States without having to reveal my age or my birthday, for example. And so a very simple example of this is, and this is like a classic example for zero knowledge proofs. Let's say two people, you and I, Nina and Kenny, right? Like we are standing in front of a cave, and this cave has an entrance and an exit, but that exit is blocked by a door with a passcode on it, right? And Nina, you know the password to unlock that door. I don't believe that you know that password, right? And so how can you prove to me that you know the password? If you do it in a very public manner, you can give me the password, but then I know the password, right? But like you don't want me to know the password. Only you want to be able to exit through that door. And so what can we do? We can do a little test, right? Like if you can prove to me that you know the password, that's good enough for me. And so I take a few steps back so that I can see the entire cave. I see the exit over here and the entrance over here, right? And you can go into the entrance, and as long as you can come out this way, that proves that you know the password, right? Otherwise, you can't exit from that side. And so that's a very basic example of like a zero knowledge proof, but it's a little more complicated because, that's just a one-time thing. But in a zero knowledge proof, there's, I guess you can say that you have to statistically prove that it's not just by chance, right? So like another good example would be colorblindness. I want to prove to you, Nina, that I'm not colorblind. And so you give me two balls, or you have two balls in your hand. One's a red ball, one's a blue ball. And you put it behind your back and you shuffle it. And then you bring the balls out and you tell me to point to the red ball. And I point to the red ball, right? And I've proven to you that I'm not colorblind, kind of. You could be like, okay, that's just a really good guess, right? So I'm going to do it again. And then I prove it to you again. And you're like, okay, could be still a really good guess, right? And we do this 1,000 times. And I prove it to you accurately 1,000 times. By that time, it's statistically improbable that you are, or that I'm, just guessing. And so at that point, you're like, okay, Kenny's probably not colorblind, right? Can I prove with like a purely is it purely 100% chance that I'm not colorblind? Close enough. Right. And so that's kind of where the mathematics and the statistics and the computation part comes in, which gets into another sort of problem or bottleneck. Anyway, hopefully that was a helpful introduction into, what a zero knowledge proof is.
Yeah, it's very easy to understand the concept, but when you talk about the mathematical, the formula behind it, the algorithms, I guess that could make anyone's head spin. But we're not going to get into those topics today, but we'll just try to, educate everybody about this, this very promising technology that's going to, a lot of people believe will shape the future of blockchain applications in the future. So that's a great explanation on ZK proof of cryptography. So But actually, when I looked into ZK proofs and I read a lot of there have been a lot of papers written on it, a lot of academic research. So it actually has a long history. So just very briefly, give us a little bit, historical perspective on how this field of research has been developing in the past and how it has been applied in the blockchain sector.
Yeah, so the irony is that despite how long research has been happening around zero knowledge proofs, the real application and use case, I would say, was really catalyzed by blockchain. And it's because blockchain, the decentralized, trustless nature of data, really is, I think, a critical component to utilizing and leveraging zero knowledge proofs. But with that being said, so zero knowledge proofs was an idea created by Silvio Micali and a few other folks. And the reason why I remember Silvio Micali is because he went off to create Algorand, and he was also one of the professors at MIT. And during that time, right, I think it was like in the late 1980s, it was largely theory. And so what I mean by that is the computational power it takes to really been achieved until recently, right? And so before that time, before the hardware is available, right, it's really just largely theory and mathematics. But now, right, like with sorry, go ahead.
That sounds really like the story of AI, because the AI research has even longer history.
Yeah.
It's just like it was constrained by computational power in the past, so we weren't able to actually use it or apply it as we can since computers becomes much stronger and powerful. Oh, that's interesting.
Exactly.
Yeah.
Yeah, that's exactly what happened with zero knowledge proofs. Because if you think back to the example where we're playing that ball game, right? Imagine we're doing this literally 1,000 times. By the 1,000th time, your arm is so tired, right? That's exactly what a computer processor is doing. It's running an equation over and over again, right? And by the 1,000th time, you want it to run 1,000 times in under, I don't know, a second maybe. That would be awesome. But the constraints of the hardware means that back in the 1980s, it would probably take days maybe to run. I mean, don't quote me on that. It's probably a lot longer. But now it's a lot faster. So being able to apply zero knowledge proofs to applications, to use cases, is a lot more practical than it used to be. Yeah, and so we see it a lot in the blockchain space. I think that's where the zero knowledge proof value proposition is really critical. Because if you think about like a centralized solution, your entire trust depends on the centralized service provider, right? And so an example of this could be Facebook or Meta, right? Meta holds all your information. You trust Meta not to give away any of your information. I mean, whether that's true or not, right, is another thing. But Meta is supposedly the protector of your information. They offer the privacy to your account and your information, right? And so like there's a centralized service providing this. But when you're looking at a decentralized solution like blockchain without some sort of privacy layer, then you get into a problem of literally anyone with an internet access can see all the information about every single interaction you've made with any smart contract on Ethereum, on Binance Smart Chain, et cetera, right? And so you need to have some sort of solution to offer that level of privacy that at least you've experienced through like Web2 solutions. But you can't just have a centralized entity be like, oh, don't worry, trust us, right? Because that defeats the whole purpose of blockchain. And so you need some sort of mathematically sound, decentralized solution to offer privacy in a decentralized world. And that solution is zero knowledge proofs.
And I think there is a parallel of comparing ZK's functionality or its, I guess, functionality in the space of privacy to the Web2 ecosystem, like encryption, like end-to-end encrypted messaging. How would you which technology stack would you compare ZK to in the Web2 scenario?
I wouldn't say it's more of a comparison than it is leveraging technologies,
Or
right? I
just to
mean, like,
like help people understand, like, you can think of ZK as, in when we send emails or messages in apps or something. So
let me think about it, because the zero knowledge proof, I think, is more so to secure the data layer, right? And so if you think about it like that, then it's not really the interaction, or it shouldn't be an interaction that the user has to experience on a day-to-day basis, right? Like when they send an email from one a Gmail server to, maybe, I don't know, another email service, Yahoo, right? Like, and that happens with like multiple layers of encryption, and even the hashing that happens to even access your account, password confidentiality there, right? Like, there's a lot of different components that go into securing that message. And it's the same for zero knowledge proofs, right? Like, there's a lot of different components that go into securing a zero knowledge proof. And so I don't think it's as easy to say as, like, oh, it's like clicking the login button. But actually, yeah, I mean, it's almost like it enables you to have that sort of on-chain messaging in a privacy preserving manner. So it enables Web3 email, for example.
got it. Okay. So thank you for that explanation. And we have a lot of comments on the live comment section on Binance Live.
Oh boy.
And everyone, please, if you have any questions for Kenny, submit your question right now, and we can have him answer them at the end. And another thing I want to also highlight today is Binance Academy just today launched a course product. So we're offering free user education courses to everyone. So you can just go to Binance homepage, and you will be able to find that we offer this great educational course product for you to learn everything about blockchain, cryptocurrency, Web3. So definitely go check them out. And also, disclaimer, of course, I forgot to say in the beginning that everything we say here are only for informational and educational purposes. So nothing, as user solicitation or promotion or anything of the sort. So, okay, let's continue our conversation, Kenny. So I think you explained the history and how the application of ZK have been in the past really well, and of course, its application in blockchain is our center of discussion here. And when we come to ZK's application in blockchain, there's all this alphabet soup, right? The Snark, the stock, the Snark. I don't even know how to say them. Like, so maybe can you go through the different types of ZK's application in blockchain?
Yeah. So the different types of applications for ZK and blockchain, I think there are two main categories of use cases right now, right? Like, I think you had mentioned one at the beginning of the conversation when you were saying that you were comparing the ZK rollups to optimistic rollups, right? And so, like, the scalability side, I think you guys probably already touched upon that before. So I won't go into too much detail about that. But then there's also the what people consider to be the privacy side, right? And so the privacy side is, when you have that confidentiality for on-chain transactions, that interaction with smart contracts, verifying that you have certain components or aspects or assets in your wallet without revealing any information about that asset in your wallet. So yeah, largely two use cases: one on the roll-up side for scalability purposes, and one on the privacy side. But I know that people like to say privacy, right? But, like, I think, like, just to kind of dissect a little bit more about what that means on a ZK level, it's less just like privacy in its general term, and more, I think, the value proposition comes in with control of your own data, right? And so I think when I think this was pretty hot in like 2017, 2018, when dApps first started coming into market, and everyone was thinking about use cases. And one of the use cases was, controlling your own data for advertisers and all that stuff. And so, like, you can earn money if you decide to expose some aspects of your data to the advertiser. But if you expose it without zero knowledge proofs, then as soon as the advertiser receives that data, they now have that data, right? And so it's like a one-time use, one and done. But with a zero knowledge proof, right, now you can still reveal particular attributes about yourself without identifying what those attributes are. So back to the example of, I can prove to you that I can drink alcohol in the United States without revealing to you what my birthday is or what my age is.
Right. So could you also maybe touch on the, I think a lot of people confuse, ZK Snark and ZK Stark and ZK Snark. So maybe you can just like explain how are they different and how, what kind of problems they're all trying to solve.
Yeah, so they are all trying to solve the problem of thinking about how to provide that sort of confidentiality, right? And they can be applied to the roll-up use cases as well. But the approaches are essentially different. So a snark, it definitely has an advantage on the blockchain side in terms of the optimization of the file size. So if you think about a proof, right, like you still have to put the proof on chain. And so what's the size of that proof? It can be very, very small, right, in terms of bytes, or it can be very, very large in terms of megabytes. And so the snarks are a class of zero knowledge proofs that specifically can help with that optimization on the file size side. The starks themselves can be a little more, can be faster, right, but at the cost of optimization, right? Because if you essentially, like, the larger the file size, the faster you can do it, because it takes less complexity on the compute side to compress a file down to a smaller size while still being, for lack of a better term, usable, right? Forget the word. But essentially, the integrity still needs to remain while you shrink the file size, right? And so, like, that sort of complexity of computing the smaller file size while still maintaining the integrity, right? Like, that costs computational power. And so that's where Snarks shines, right? But in terms of that computational power, that means it's a little bit slower. But, right, when you think about a blockchain, you do want to keep the file size as small as possible. And so that's why a lot of approaches with zero knowledge proofs today are using ZK Snarks.
And could you compare that with Stark?
Oh, I sorry. I think I just did.
Sorry,
I was
I
talking
think
about
I missed that part.
the Snark and the Stark.
Okay.
Yeah, no worries, no worries.
I've been reading all the comments, and I probably
Oh,
must miss
well,
that
I
part.
wonder. Yeah, what do the
Okay.
comments say? I can't see them.
Yeah, this is on the Binance Live platform, but yeah, it's not on the back end. Sorry for that. But okay, so I understand, from what you said, I can just see the computational, I guess the demand for running ZK proofs on blockchain for a lot of applications. It can be very intensive computationally and perhaps also expensive. And not to mention the complexity of the algorithms and all the other technical issues. So what would you say are the biggest challenge right now for ZK proofs to get wider adoption in blockchain?
Yeah, so that's a really good question about, what are the bottlenecks for wider adoption of zero knowledge proofs. This is something that we're currently researching a lot at Manta Network also. And so the bottleneck is definitely computation. One of the things about that computation means that it's not just like, okay, you need a good processor, but what it means to the end user is that it can be slow, right? Because as the processor is computing that proof or generating that proof, right, you're sitting there waiting. And that waiting can be as long as like a few minutes, just to generate one zero knowledge proof for one transaction if it's not optimized, right? We've been able to optimize that zero knowledge proof such that in certain environments, it's around 2 to 5 seconds. But even that has some sort of constraints, right? We really have to jump through a few different hoops and take a few different sort of side steps in order to get to that 2 to 5 second performance optimization for the zero knowledge proof. If you were to run that zero knowledge proof directly in a browser through WASM, for example, and I'm sorry, this is getting a little too technical, so I'll try to keep it high level. Essentially, right now, by running it directly in the browser, you get rid of all the tools that are needed to generate a zero knowledge proof because the browser can generate it for you. But the problem is that it's not as fast. And so, ideally, we want it to run in the browser because that allows the user to just, play with an application just like they would like Uniswap and not have to download any additional tools to speed up their zero knowledge proof generation. But right now, right, there are bottlenecks on the compute side that constrain how fast a browser-based zero knowledge proof can run, right? And you can think about like how these constraints translate into desktop versus mobile, and what sort of optimizations there can be there as well. And so, essentially, long story short, there's just largely computational bottlenecks on the ZKP side.
Do you have any potential solutions in your mind that that's going to solve these challenges?
Yeah, so internally on the research side, we've been working on a lot of the optimization for the browser-sided zero knowledge proof generation. I think like we're getting to the point where it can be integrated as part of like a seamless user experience. And so, opening up MetaMask and then running a MetaMask transaction using Snap to interact with a zero knowledge proof verifier or generator, and then being able to generate that proof all in a matter of a few seconds, right? That's the ideal state we want to get in. Currently, right, one of the aspects or one of the components that we've built out in order to kind of help push that zero knowledge proof generation faster is what we call the Manta signer. And that signer is specifically a daemon that runs as an application on your local device. And that local device helps you generate that zero knowledge proof in a matter of 2 to 5 seconds. So yes, there's a lot of things that we're doing in order to increase that speed. And I think over time, right, like there's going to be a lot of innovation on the WASM compilation side for the zero knowledge proofs. And what that means is that more and more applications will start using zero knowledge proofs directly in browser, which ultimately contributes to a better user experience.
Okay, thank you for that. And I see someone commented that they see your reactions to my stupid question when I forgot to listen to you. But that's because I was distracted by all these comments in the chat room. But I challenge everybody in the chat room to actually, ask a serious question. This is a great opportunity to learn from an expert in the field. So don't miss out on this opportunity to educate yourself on something that's definitely going to have a great impact in the future for our industry. So I guess, Kenny, we haven't really talked. You mentioned in the beginning a little bit about Manta Networks, what you do. But since now we have went through, all these topics on the history of ZK and different ways to utilize the technology, maybe could you compare of your approach versus some of potential other popular approaches towards a future solution? How do you differentiate, and how do you see each different projects maybe are solving different problems and how they come together?
Yeah, sure. So on the Manta Network side, just to kind of give a little more detail on what we're doing is we are a layer one solution, specifically using zero knowledge proofs for private transactions with a focus on social and Web3 communications. And so I know that was a lot of buzzwords, but what that actually means is that, we specifically focus on private transactions on chain. And so, yes, there are sort of solutions out there like it, right? And so one that probably comes to mind that also uses zero knowledge proofs, a legacy one, would be Zcash. And so one of the main differences here is that we are taking a lot of concepts that are that were born from Zcash, right, and applying them to Manta Network. But at the same time, we're doing a lot of we're adding a lot more feature richness as well as performance optimizations. And so right now, in terms of the research and the back end, right, like building out that zero knowledge proof generation speed, right, we have 10x the generation speed of Zcash. And also in terms of feature richness, I think one of the big differentiators here is that, we are not specifically focusing on one cryptocurrency, right? And so, for example, MantaPay, our privacy payment product that'll be launching on Calamari soon, it doesn't just take one specific token, right? And so we don't have a privacy token per se. We allow users to bring in crypto assets, tokens from various other blockchains and privatize those tokens. And so it's more like a bring your own token model. And ideally, the ideal state would be, any token, any cryptocurrency can be a private cryptocurrency. And so that's really the value proposition that we're aiming for at Manta Network. And we're specifically, like I said, focusing on social and Web3 communications because we think that that's a huge aspect of decentralized identity, which is kind of core to where, Manta Network kind of started. And so, we definitely want to play a little more in that space because we think a lot of the use cases around social communications can't happen without privacy.
Mm-hmm. That is really exciting and very interesting. How the space is evolving. I guess my last question is about the whenever you talk about privacy, it's sort of like you have two split camp of opinion. One is, privacy is a fundamental human right. Another is like, oh, this enables all the criminals and, all the bad actors and, hide their tracks and all that. So, I know this is I guess a concern that ZK community have faced in the past. I'm wondering, like, what's your take on this issue?
Yeah, so I'd say that for everyone in the camp that privacy is just for criminals, then I challenge you to email me a copy of your past 6 months bank statements and give me all your passwords to all your accounts, right? Like that's the answer is no, right? Like who in the audience will do that? No one, right? Because the reality is that I think there is a narrative when it comes to being critical about privacy that people say, oh, it enables all this bad stuff. Well, the bad stuff has been happening long before zero knowledge proofs. And so it's not that it's enabling it, right? I think like the bigger picture is that I do believe that privacy really is a fundamental human right. And I think that governments really recognize that as well. There are, for example, Tornado Cash, right, was definitely one of the most recent incidents where it seems like, governments are acting against on-chain privacy, but I don't believe that's the case. I think OFAC, their mission is specifically to focus on the enemies of the United States. North Korea is an enemy of the United States. North Korea used Tornado Cash to funnel money and launder it. And so, OFAC had to take action. But whether their action was the right one or not, I'm not here to debate. But the point is that OFAC took this action, not like FinCEN, which is more focused on financial crimes, right? Not the SEC, which is focused on the security side, right? And so you have to ask yourself, like, what was the purpose of targeting Tornado Cash? I don't think it was because there's a statement coming out that is saying, oh, online or on-chain privacy is wrong. Right. I think it was more so just a question of like, okay, like who was using that? And that does get to the argument of like, the criminals, which is true. But at the same time, right, there's a huge, I'd say, underserved market, unaddressed market of people who just frankly need privacy. Literally everyone here uses privacy every single day, right? Like you don't show your children your Binance accounts, right? You probably don't show strangers your Binance accounts, right? You don't show them all the losses that you've had or the wins that you've had. So why? Because it's password protected, and guess what? It's private to you, right? And so if you have all this already in this Web2 space, why is it such a hard demand in Web3, right? In this sense, we're not trying to make Web3 any different. We're just trying to offer Web3 services in the same manner that Web2 services are already offered, right? But in a trustless way. And so I think privacy is a really critical component of that. And even on the governmental level, as a government, right, especially if you think about Web3 5 years from now, 10 years from now, right, ideally in the bullish term, right, like 1 billion people are using it, 3 billion people are using it. There's tons of use cases. Every single data point from every single 3 billion people around the world is another data point for surveillance for enemies of the state, right? For bad actors, right? These are people that the government needs to be concerned about and for the sake of the safety of their citizens. And so even on a governmental level, right, thinking about the future of Web3, the future of blockchain, I think that privacy will play a critical role in that. And so, I think overall, the conversation around privacy being just for bad actors is, frankly, a very narrow-minded scope. And the broader picture demonstrates that privacy really is a necessity.
Very well said. Thank you. Thank you for that. And we have someone comment that I don't even show my Binance account to my significant other. So yeah, I think privacy very important. And I guess I'm not looking, I'm not seeing any serious questions on the topic today in the chat, but we've covered basically, what we want to cover today. Thank you, Kenny, for your awesome answers and educating us on this very important topic. Is there anything else you want to add, like to what we have talked about today?
Not really. I mean, if you guys want to chat, if you have any more questions, my Twitter is always open. My Twitter is super anonymous K, all one word. Yeah, and more than welcome to just ping me on there, follow what we're up to at Manta Network.
Awesome. Thank you so much. And keep up the good work at Manta Network. And thank you so much, Kenny. And thank you everyone today in the chat, on the live stream today with us. So everything will still be online, following us on YouTube and also on Binance Live. So you can always come back and watch it again if you need to learn more on the topic of ZK proofs. So, all right, with that, goodbye, Kenny. Hopefully we can meet one day in person.
Yeah, thanks for having me. Appreciate it, Nina.
All right.